variables. The one explained in this section is called the Pearson product moment correlation coefficient, PPMC.
Great. I'm just going to run back a couple of things to make sure all the slides get on the tape. But yeah, so again, remember R, rho is the Greek letter for the population correlation coefficient. We always take, that's the Greek letter rho, so the kind of the our language version, the regular version of that in the alphabet would be R. So that's why our sample correlation coefficient is R. So let me just circle those guys so you guys are clear. Population correlation coefficient, rho, and then we have our sample correlation coefficient, R. And then we have, again, this is the one that you guys had your negative relationship, your graph that you guys did, and then here's the example of no relationship with age and wealth. Okay. All right, so this one is where we start getting down to the nitty-gritty of this stuff. How about Kaya, go ahead and read.
Correlation. The range of the correlation coefficient is from -1 to +1. If there is a strong positive linear relationship between the variables, the value of R, rho, or no,
No,
just
R, yep.
will be close to +1. If there is a strong negative linear relationship between the variables, the value of R will be close to -1.
Great, thank you. So in other words, if things are perfectly, if it's there's a positive relationship, it's going to go like this at positive slope. If it's a perfect relationship, it's going to be a perfect line. So for example, when I buy muffins, it costs me $3 each. One muffin costs me $3, two muffins cost me $6, three muffins cost me $9. That makes a perfect line. Right? It's a perfect relationship. If you look at the money in my pocket afterwards, right, I buy one muffin, I lose $3. I buy two muffins, I lose $6. I buy three muffins, I lose $9. Right? That's a perfect linear correlation, but with a negative relationship. Right? Again, that's going to be a perfect line. So that would be -1. That's the perfect line with a negative slope. The other one would be +1 because it's a perfect line. So the 1 indicates a perfect line. Doesn't matter what the slope is, just that it's positive. Right? And it's perfect, as opposed to kind of fuzzy, a fuzzy-ish line. This one here, no relationship whatsoever. So 0, it's kind of nice because 0 is sort of like a big circle, just random dots. And a random, like I kind of think it was like one big ball of dots, randomly. So no relationship whatsoever. That's 0 correlation. +1, perfect linear. -1, perfect linear but negative slope. So you guys take a minute and on your sheets, write down, flip the page. There are 7 things there. Assign each of them a number. I would suggest doing the 1s and first, and then maybe the 0, and then working your way out.
I don't see 9 anywhere. You see a 9?
We're doing these numbers.
So write down next to each one or below each one what number you think it is. Or about it, doesn't matter. Just write down numbers for what you think those correlations are. Writing numbers.
seen these numbers right here. But then,
That's just share the bed.
Because that's what the same thing is this one, right?
Wait, I know. And you say that right. I got you.
But they're further apart.
you think we're having that?
So Caesar, we're gonna go Caesar first. Give us one. And then Joseph. And then Richard, and then we'll figure out the last one in a minute. All right, so Caesar, give us one of the numbers. Just pick one. I don't care, whichever one you want. Like so, like what's number one?
The third one.
Which one is positive one? I'm sorry, what'd you say?
The third one.
The third one. Positive one. Great. Joe, which one? Give me another one.
0.8 would be the second one.
0.8 is the second one. So let's get back to that in a minute. Rachel, give me negative one. Yep. And then I'll pick somebody randomly for this last one. So 0. Yukaya, which one's 0?
The one with the black dot.
Yep. Great. So Joe picked this one for 0.8. Why? Because what do we have left of the positives? 0.5 and 0.8. That's these two guys. Everybody follow that? Which one's more like a line?
The second one.
The second one. So this one should be closer to 1, because 1 is a line. The kind of nice thing about ones and negative 1 is that the number 1 is sort of a line itself. Do you guys see what I'm saying? And 0 is sort of not a line, it's a circle. So that makes it kind of easy to kind of remember that. So that's why this one's 0.8, because it's more like a line than this one, which would be 0.5. So then these two down here, I'll give you guys just 15 seconds, 10 seconds, 5 seconds to be able to figure those last two out. All right, so these two, which one's more like a line? Yeah, this one here. So what am I looking at? I'm looking at negative 0.3 and negative 0.8. Which one should this one be?
Negative 0.3.
Negative 0.8, because that's closer to a line. Line is 1, negative 1. So negative 0.3. Good?
Yeah.
All right. That'll be the easiest problem on the exam that a bunch of people will totally miss. Okay, we'll talk about that one.
Wait,
There we go.
one last point.
Okay. So now we need to figure out how to find the correlation coefficient. This is the formula for the correlation coefficient. That's okay because we have this great thing. When I feel so old now. I went to, I don't know if I told you guys, but not last week or the week before, I went to this reunion at my sorority a long time ago, and we were there, and they were like, and I was talking about, when I was at Cal, registration fees were $800 something for the semester, for the whole semester, $800 something.
Damn.
Right? And my friend was like, yeah, when we were at Cal, Yogurt Park, this place we get yogurt and they put toppings on it, was $1.10 and now it's $4.10. That's totally crazy. So now I feel like this old person is like, well, when I was in college, you know. You guys ever remember those old commercials? The old guy sitting on Jesus sitting on the porch and the guy was like, I was young. We had to walk uphill in the snow to school both ways. And he was like, well, when I was young, we didn't have sunglasses. We just squinted all the time. It's so funny. But yeah, when I was young, we didn't have these great calculators. Right? So we had to like do this frickin' stuff by hand. Like we can do like one number, but we'd have to like add all that stuff. It was a whole pain. Right. However, you guys have these great, nice, nifty things. So we're gonna do this together. We're gonna use our lists. But see that big complicated formula on top? Really, the neat thing is, if you look at this part here, x minus x bar divided by the standard deviation, that's just the z-score for that x value. And this one over here, y minus y bar over s standard deviation of the y's, that's just the y, that's just the z-score for that y. So if we took every single point found the z-score for the x, z-score for the y, multiply those together. Did that for every single point, and then add them up and divide by n minus 1, we would get the correlation coefficient, which is super cool. That's really, really neat. But we're going to go through using the first formula. You guys are going to think I'm crazy. That's okay. And we're going to work this out. So everyone bust out your calculators. We're going to talk about a few things real quick first, and I'll help you figure these things out. So just so you're aware, obviously you guys know n is the number of pairs of sample data, right? Number of points you have. Sum of the x's, that's the first one. That means adding up all your x's. You guys are pretty good with that one. You've seen that before. This one, sum of the x's squareds. That means first, you take every x value and you square it first, and then you add them up. Good? The next one, sum of the x's in parentheses squared, means you do parentheses first. First you add up all the x's, and you take that big number and you square that. The sum of the xy's, you take every x value multiplied by its y, because they're in pairs. You do that every single time, and then you add up those guys. And then here is your linear correlation coefficient, and obviously rho, which it sounds like you guys are picking up nicely, which is great, is your linear correlation coefficient for your population. So let's go ahead and try this one. I feel like you have this in your. Yep. So we're going to put cars in list 1. And we're going to put our y's in list 2. So everybody do that. How do you do that? You go to stat, edit. Maybe you have to go to list 1 up where you're actually in the L1 and hit clear enter, maybe. Right? Maybe you have to do that. Put them all in there. You can overwrite them if you need to. Yeah, we're at the bottom of page 2. Right here, bottom of page 2. The one we're doing together. And you can use your keyboard. You guys know that. It's really easy if you use your keyboard. Pop these guys in there. Okay. So here's the thing. Once you input it, then you got to stare at it with your paper and make sure that you've matched them all up right. Because if you make a mistake when you input them, then everything you do from then on is total garbage. Right? So double check your numbers, because the calculator will do whatever you give it. So if you give it something wrong, it's going to be totally wrong.
Where did you get that?
That's why I thought.
Oh, list 3, ignore list 3. My list 3 is, okay.
Okay.
Okay. So everybody's good? Everybody has his input? Now, we need x times y. So I'm going to go up to list 3, and I'm going to do, what do I want? List 1's my x's, list 2's my y, so I want
L1 times L2.
L1 times list L2. Yep, so I'm going to do list 1 second L1 times second L2. You have to be in where your marker, your black spot is on the L3 to do this. If you're here at -5 point, in this spot down here, it's not going to work. You have to be up where your cursor is actually, the black spot's on L3. Second L1 times second L2. You can see it popping right here. Hit enter, and boom, they go right in there. Super cool, right? Now, I need the sum of the x's and the sum of the x's squareds. Stat, calc, 1 bar stats. I'm only going to do the one variable at a time. And I'm going to put in second L1. That gives me my sum of my x's and sum of my x's squared. You guys see that? 153.8 and 58.59.26.
Wait, what did you put in?
Stat, calc, 1 bar stats of just L1, second L1.
L1?
That's where my x's are.
Oh.
And I'll give you my x bar, my x square, some of my x's and some of my x's squareds. So now I'm gonna go back to my paper. And I'm gonna put in, some of my x's was 153.8. And some of my x's squareds was 5859.6.
0.26.
Oh, 0.3. I'm gonna round it to one decimal place. Everybody okay with that one? And then do the same thing with list 2.
So this time you'll just put second L2? That's it?
Yeah.
You won't put no line one?
No, you know what? Cool. All right. We can do this. Stat, calc, 2 bar stats. Do you guys see that one? You have to do that one. And you do second L1, comma, second L2. And it will give you all of them. It gives you your X's. And then it assumes, and then there's a second list you put in, it gives you your Y's. There's some of your Y's and some of your Y squareds.
Oh, wow.
And then look, gives you some of your XY's. So that's even cooler.
Wait,
Yeah.
I need to
So it's 2 bar stats, because we have 2 variables. So I just figured this out right now, sorry guys. Calc, stat calc, 2 bar stats, 2 variables, enter, second L1, comma, second L2, you gotta feed it both. 2 bar stats, L1, comma, L2.
Oh,
Or you can just do it, or you can just do 1 bar stats and just do them separately, that's totally fine too.
Wait,
If you do them separately, how do you find the sum of the xy?
Oh, then you have to do 1 bar stats of L3. Yeah. So yeah, so if you do them separately, just do 1 bar stats for L3 and do the sum of the x's for your of list 3. So that's where you have your x times your y's. But this one you don't even have to
no,
do that.
that's not the same as...
And you're
Okay.
rounding to one decimal?
So then my y's, my y bar was 18.7. Some of my xy's was 80.67, 80.7, I guess.
So just one decimal.
I don't know. I'm
You're gonna need a whole
I'm
different
having
number.
issues right now. I'm not really sure. And then the sum of the xy's is 682. I'm gonna do 4 sig figs at the most.
I got 15.7.
Okay, so this is. So you guys have something along those lines, yeah?
I'm sorry, can you
18%.
show how you do it here? Mine's not coming out.
Stat. Calc. Do you want the 1 bar stat way or the 2 bar stat way?
2 bar stat.
2 bar stats. Enter. Second L1, comma, second L2. Oh, you did. Carla, when we talk about, yeah. All right. So you guys should have. You guys should have these numbers. You know what? We'll get that. We can work out the details later. But just get these numbers down because otherwise, keep going down. Arrow down. So you have to arrow down to get to the rest of it. Keep arrow down. Go, 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 go. See, they're all right there. Some of the y, some of the y squared. Keep going. So you have to arrow down to get to the rest of the pieces. It gives you the first part, and then you have to keep arrowing down to get the rest of it.
I got a whole different angle.
All right, so if you guys look at it, see how it only has room to give me this part here. If I want the rest, I have to arrow down, and it gives me the rest of the stuff. So everyone see that?
Oh, okay, now I do.
Arrow down, and you have it all. Okay, everybody should have these numbers written here now.
Your regressionist
Okay, so now we need to find our R. So we need our N. What's our N?
6.
6 times the sum of our xy's minus the sum of our x's times the sum of our y's. So, and divided by the square root of 6 times the sum of our x's squareds minus the sum of our x's, quantity squared, multiplied by n times this number minus that number. You gotta plug in all those numbers. Let's see, x times y, that's 682.8. Some of the x's, 153.8. Some of the y's is 18.7. Some of the x's squared. 5859.3. This is 153.8 squared. This is totally like the way of finding variance.
80.67?
Yeah. Oh, sorry, this is supposed to be squared. Square that, square that. Make sure you square those.
Do both have to be squared?
Just those little guys, the small, these smaller numbers get squared right here.
But both
And
are
right-
under, right?
Yeah. So these ones get squared, then you subtract them. So I'm gonna kind of do it piece by piece. 6 times 682. 682. 8. So I'm just kind of start working this through and find that number.
So are we multiplying both these brackets and
Yeah,
then
multiply,
square
so those two brackets you get multiplied and then you square root them. Yeah.
I'm trying to do it all one swoop and it didn't work.
This is what you guys have so far, yeah?
Almost there. Here we go.
Yeah.
So good. Better watch out, girl. I'm coming for your brand.
How many steak figs do you want?
Probably 4 is fine. I probably did too many last week. So this is what you guys should have along the way, kind of, right? I think. So I got,
Please.
0.982.
Yes.
Yes.
Yeah.
Great.
Wow.
All right.
Probably.
That's just
So much work.
Right.
If I got one little thing wrong, everything wrong.
Yeah, exactly. So yeah, if you screw up one thing on your list, then it all goes wrong, right? Okay, so here's the thing. Hold up, hold up,
Big
hold
brain
up.
moves today.
So, you see the very, very bottom? Do stat, test,
Oh, is it?
and then arrow up. Lin Reg T-test. You arrow up and it'll get there faster. Everybody got there? Stat test, Lin Reg T-test, not interval test. Stat test, Lin Reg T-test. You got to arrow up to get there. It's all the way down. Lin Reg T-test. It's written on the bottom here. It says,
0.982.
put, right? Yep.
T-test.
Everybody there? Yeah.
Wait, what's the regular EQ, the red EQ?
Just do Lin Reg T-test.
Yeah, that, I'm on that, and it's,
Okay. Oh, leave that blank.
okay.
So then my X's are in list 1, my Y's are in list 2. Frequency, leave that as 1.
Is it always going to be 1?
It's, yeah, and it's always going to be not equal. Always. Always going to be not equal to. And then leave that reg EQ blank and hit calculate. So it gives you the stuff, right? Arrow down, keep arrowing down, and you'll get to R. 0.98197.
So we actually don't have to do it.
That's
all
right.
right.
So you gotta do it one time,
That's
just so you can realize that's the work that goes into this and appreciate it.
That's annoying.
Well, no, trust me, there are classes that we make them do this every time.
Thank you.
You guys do it once, you can kind of appreciate it.
Mad appreciation.
And then you can just do this. Okay. Yeah.
I was like, damn.
You guys quiet.
You want us to just do it like this instead of trying to calculate? Because that bottom
Yes.
part was like,
Yes,
okay, so just do it like this.
Yeah.
Okay.
exactly.
What would you say the red EQ?
So R is
Leave it blank. Yeah. All right, so you guys do lab problem 3. Find,
1,
you
3, 4,
put these in there
8 here.
and find the R for that. Find R. then if you need to clear list 1, go up to your cursor's on L1, hit clear enter, and that'll clear the whole thing. But I think you can just overwrite it, because I don't think it's larger.
You can.
Yeah, just overwrite it. So 6, 2. Double check your numbers, make sure you have them correct. If not, everything you do is going to be garbage and you'll have no idea why. And then find your R. Looks like people are done. We can move on. You're not even. It's 7 on top, that should be, not 7 should be there. Yeah.
So do we have a line?
Was that?
Do we have a line?
You got the video.
So that's when I put the,
Yeah, then do the literature test. All right, so everybody has them in?
What goes in L3 again?
Nothing.
Oh.
So nothing in L3. So now you guys are going to do stat, you guys play it. Stat, stat test, arrow up, because I'll get you there faster, lin reg t test. List 1, list 2, frequency 1, not equal to, leave that blank, calculate. And then arrow all the way down to get to your R. Negative 0.944. So much easier. All right. So I'm going to show you guys the steps of hypothesis testing for this. It's very basic. You guys can use hypothesis testing every single chapter from here to the end, every single section. So here are H0 and H1. H0 is always that something is equal. In this case, rho. Rho is equal to 0. Right? So that's how it's always going to be. It's always going to be rho is equal to 0. H1 is always going to be that rho is not equal to 0. So in other words, null hypothesis is always no. In this case, no correlation. Not aligned. No line. That's an hypothesis. H1 would be, there is a correlation. There is a line. It's a line. All right. So anyway, so that's your H0, H1.
so it's only 0?
Yeah, always. Because remember, 0 is no correlation. Right? You guys remember 0 in the middle, no correlation. Positive 1, perfect line, perfect correlation. Negative 1, perfect line, negative correlation. All right. And then, so first one, step 1 is your hypothesis. Step 2 is finding your critical value from the PPMC table, which I will give you when we get back from Thanksgiving. We'll let you do these tests. Step 3 is finding your test stat like you just did a second ago. Step 4 is decide whether or not to reject H0. So here, I'll show you that in a minute. And then step 5 is summarizing claims. So this is going to be really similar. Here's an example. Is this in your sheet? Yeah. Yeah, it is. It's in the very bottom. So let's do this last one together. It should only take us a couple of minutes. You guys stay focused. So number 1, always, H0 is that rho is equal to 0. H1 is that rho is not equal to 0. You guys should write that at the bottom of the page, right here. Right here, very bottom. Right, example, test for, right? Right here. All you have is this part here. Just the bottom of your 3rd page. Page that we're on. Where it says example. Alpha's 5 and R is, it says right here.
Oh.
Okay?
So I have a question.
Oh, okay.
You know how like the slanted P is rho?
Yep.
Can we just write rho?
RHO?
Yeah.
I'd be okay with that.
Okay.
Yeah, I'd be okay with RHO. Yeah, because the thing is, you don't want to, if you write P, you're going to get totally confused with proportions and everything's going to be totally wrong, right? That's not good. So do not use P. You want to use RHO, that's fine. Step 2, find my critical value. In this case, they've given it to you. Oh wait, they didn't. Here's my table. So here my alpha is 0.05. Degrees of freedom, because we have 2 variables, it's n minus 2. So what's my n? I have 6 items. Everybody follow? 6 pairs. 6 minus 2 is 4. So I'm going to go along here. 4, alpha is 0.05. Looks like 0.881. Everybody, does everyone see that? So here, my degrees of freedom 4. Okay, here, alpha is 0.05, so it's 0.811. So it means I'm going to draw a picture. Here's my picture, guys. From -1 to 1, here's my middle, and I need 0.811. I'm going to shade. That's my critical value. And there's always a matching -1 as well, because it's always going to be two-sided. So positive, negative, 0.811. That's my critical value.
Are we gonna get one of those tables?
Yes, when we get back from Thanksgiving, when we actually do these problems. Right now, I'm just going to show you the basics. Step 3, find my test stat. And I've already given it to you in this problem. It's 0.982. So where does 0.982 go in this slot, guys? Yeah, way over here. It's between 0.811 and 1. Everybody kind of follow that? So it's over here. Am I going to reject? No. Is it in the rejection region?
Yes.
Yes. So we're going to reject H naught. So then, here's how this one gets phrased. Enough evidence, you guys are familiar with that, to evidence, and these are pretty much probably almost all going to be supporting claim. To support claim of relationship or correlation, you put relationship if you don't want to put correlation, correlation between, what are these things? Cars and income, yep. Cars and revenue. Great. Pretty much the same as everything else, right? Yeah. And minus 2 because we have 2 variables now. Before we had only 1, we have an x and a y, so we subtract 2 now.